1000 over e to the 1.5. So we should be getting the minimum amount necessary to live in retirement for 30 years, withdrawing 50,000 per year. So exponential e to the 1.5. Well, I'm getting, let's keep in mind, this is in thousands. So we need 776,869.84. So this is again, our P sub 0. So this is the amount you need to have in your account today to guarantee that you can live as a retired person for 30 years, withdrawing 50,000 per year. This is again the minimum. You can always modify this model if you think you need more every year in retirement, or if you think you will live longer. If you retire early, for example, then you would have to adjust this number as well. This number seems reasonable, but to be on the safe side, I would drop that to 4% maybe. So any questions on this regarding this example? Any questions? All right, so let us take a look at one more example, and after that we can probably try another problem on your own. So let's try example 312. Example. So here we have the following situation. You decide that you should put a fixed percentage raw of your salary into your retirement account. So this is what we know, that raw is a fixed percentage, of your salary, What value of raw will achieve this goal? So we still probably, let's see, we have to work with the same numbers. 5% compounded continuously, you still want to withdraw let's see. So again, 5% per year, and then we have to, we have to first discuss the salary. So let's say your current salary is 35,000 per year. We assume that your salary will grow at 4% per year. So salary today, this is the initial value of the salary, 35,000. This is your salary today, and you assume that your salary will continue to grow. Your salary grows 4% per year. So this is probably a reasonable assumption because it's a little more than the inflation rate. However, I wouldn't be so sure. I would probably make this less. In real life, salary could be staying the same for a while. So yeah, let's pretend that salary will grow 4% per year. And we will first try to build a model for the salary growth. So salary is going to grow 4% per year continuously. So this is the model for salary growth. So if you solve this equation, this is again the same as Malthusian model for population growth. So we know that solution to this system, this initial value problem, is S sub 0 times e to the power 0.04 times t. Or we can say 35 times e 0.04 times t. So this number here, 35, is in thousands. Are there any questions so far? So again, this assumption, I wouldn't probably be so sure. I guess it depends on what kind of job you do. But I don't think salary is going to grow exponentially as predicted in this model. You can always adjust it, but let's work with this model anyway. So this is the salary for any given t value. We're going to return back to the retirement planning now. So we're going to assume that your retirement account will earn an interest rate of 5% per year compounded continuously. So retirement account. Now let's look at the retirement account. So we assume again that 5% or 0.05 per year compounded continuously. So P of T will denote the balance in thousands of dollars in your retirement account. So this is the balance, right? Balance at time T in this retirement account. So then we know that derivative, the rate of change of the balance, will be equal to 0.05 times P, as usual, because we're assuming that the interest is compounded continuously, 5% per year. And then we have to add, so this time we have to add some fixed percentage raw of the salary, and the salary grows according to this formula. So let me 35 e 0.04 times t. So we have to find this fixed percentage raw of the salary, which is needed for, let's see, let's write the question, find raw so that after 40 years, you have $1,600,000. In other words, $1,600,000 in your account, in thousands. So find that percentage needed, percentage of your salary needed to get $1,600,000 in the account after 40 years. Okay, so this is the goal. This is how much you want to have after 40 years. So you want to work for the next 40 years and then retire with this amount. All right, let's try to figure it out. So this time let's see, P of 0 is 0. We're assuming that we started with nothing. So we're going to solve this differential equation. Rho is just a number. This one, is it linear?
Yes.
Yes, this is linear. Therefore, we continue as usual. We find A of t, which is the number in front of P, and U of t will be e to the negative 0.05 t, just as in the previous example. Are there any questions about the model? All right, let's multiply both sides by this integrating factor. So we have P prime e negative 0.05 t. We subtract this quantity from both sides according to the method. So here we have rho 35 e 0.04 times t times e to the negative 0.05 times t. So this is the right-hand side, and we should be able to combine these two exponential functions. So let's see what happens here. This is a derivative of the product. So P prime times integrating factor and then plus P times derivative of the integrating factor seems correct. On the right-hand side, we have e to the power negative 0.01 t. I added the exponents here. Do you agree?
Yeah.
Excellent. Let's integrate as usual. Keep in mind, rho is just a constant, so we treat it as a constant. And finally, there should be dt here, so negative 0.01 t. And then we have to add some c, constant c. All right, so now we just need to divide both sides by this exponential function to isolate p of t on one side. So we have p of t equals, and also I want to simplify 35, but well, it's actually 3,500. So negative 3,500 rho e 0.04 t and then plus c e to the power 0.05 t. So this is what I'm getting for the general solution. Please check, are you getting the same?
That's what I got.
Excellent, very good. So our next step is to find C using the initial condition, right? P of 0 equals to 0. We're assuming that you started at 0. So if you substitute 0 for t, you will get e to the power 0, which is 1. And from this, we see that C equals 3,500 times rho. And from this, we're getting our particular solution will be P of t equals negative 3,500 rho e 0.04 t, and then instead of c, I'm going to write 3,500 rho times e to the 0.05 t. So this is this is our particular solution. This is, I'm going to box it. You can see it depends on rho and t, right? T is an independent variable.
Professor,
Perfect.
can you bring the paper down a bit?
Yes, I'm sorry, yes. Is this better?
Yeah.
Okay, perfect, thank you. So here's the particular solution. We're ready to use it. We have to find rho from this, right? So we're going to substitute this information. We're going to substitute 40 for t. So we want to plug in 40 years for t. And we're going to plug in 1,600 for P of t, the amount in the retirement account. So again, we want to have this is $1,600,000 on the left-hand side. So we have minus 3,500 rho E 0.04 times 40, right? I substituted 40 for t. And here as well. So from this, we should be able to find rho. I'm going to first simplify in the exponent 0.04 times 40. It's 1.6 here. And this one will be 0.05 times 40. This is, the exponent is square. So let's isolate rho on one side. So we get 1,600 equals negative 3,500 e to the 1.6 plus 3,500 e squared times rho. I factored out rho on the right-hand side, and I'm going to divide both sides by this expression inside parentheses. So we get 1,600 over this entire sum. So if I divide now, I should be getting 18.77%. So 18.77% of your salary, you have to deposit this percentage of your salary, approximately 19% of your salary every year, right? Every year. So if let's say your salary is 35,000, right? 35,000 per year, the first year, right? This is your initial salary, starting salary. If you multiply that by 0.1877, so this is the number to deposit during your first year, 6,570, right? Approximately $6,570. Well, it could be not easy to make a deposit like this. But if you keep depositing this way, according to this model, you should end up with this amount after 40 years, right? So any questions regarding this example? So let us practice now. I'm going to ask you to do a problem, number 9, which is supposed to be a homework problem, but I don't see any harm if you start it right now. So number 9. So let's read the question. Let's, I'm not sure where I have this file. Well, here it is. So again, this time we will look at number 9. And I can zoom in a little more. So Jose is 25 years old. His current annual salary is $28,000. Over the next 20 years, he expects his salary to increase continuously at a rate of 1% per year. He establishes a fund paying 6% annual interest, compounded continuously with an initial deposit of $2,500 and a promise. I'm afraid, let's see, let's move to the next page. And a promise to deposit a fixed percentage of his annual income each year. Find that fixed percentage if Jose wants his balance to reach 50,000 at the end of the 20-year period. So clearly this is not a retirement plan. It's just, he's trying to save some money for something, right? Because 50,000 for 20 years, well, he would be 45 in 20 years, so he wants to save this much over this 20-year period. So we need to summarize the information, write it all down, and then solve this problem. So we know his current annual salary, it's $28,000. Am I right? So I'm going to switch back to paper. And I'm going to write down his initial salary is $28,000. This is given. So he started at 28,000, and over the next 20 years, he expects his salary to increase continuously at a rate of 1% per year. So continuously means we can use this model right here, this type of model. So S prime derivative, the rate of change of the salary is 0.01 times S, right? And S sub 0 equals 28. So this is the salary growth model, which will give us the exponential solution. So S of t, we know, will be 28 E. So in this case, the rate of growth is 1% times t. Do you agree so far? So he establishes a fund paying 6% annual interest. So the fund, 6% per year, continuously, with an initial deposit. So we have the initial deposit of $2,500. So he committed to deposit a fixed percentage of his annual income each year. So rho is a fixed percentage of his salary, right? What that fixed percentage, if Jose wants his balance to reach 50,000 at the end of the 20-year period, so that means amount after 20 years, his balance has to be equal to 50,000, right? And we want to find his fixed rate rho, okay? So I wrote down all this information, so you should have it also, probably write it all down on paper, copy this information on paper. And once you copy it down, start solving the problem. Again, you want to find this fixed percentage rho. Let us start breakout rooms. And again, I noticed that you don't really talk too much to each other. I strongly recommend that you don't be shy, talk to your classmates. If you have questions, you can ask them. or offer your help. If you solve the problem, offer your help, ask them if they need any help. So it's, it's a good idea to communicate with your classmates. So let me start breakout rooms. Please join and again, discuss with your classmates.